All right, hi guys, and welcome to another session. So, in this session today, we are looking at a very recent paper. In fact, the most recent paper at the time of the making of this video, which is the March 24 paper. And that's a great paper for you to do on your own without any friends, without any distraction, just so that you know how solid your prep really is. So, let's get started here. So first question, which row shows a physical quantity and its base SI unit in the SI system? So it's current and it's amperes. So this is true. Current is a physical quantity and these are the base units. Force is a physical quantity and this is not a base unit. Mass is a quantity and grams is not the base unit. Temperature and degrees Celsius is not the base unit, it's Kelvin, which is the base unit. Right, so this is wrong as well. Let's have a look at question number 2. A car of mass 850 kg is traveling in a horizontal straight line. The diagram shows the two horizontal forces acting on the car in opposite directions. So we see a 1600 Newton force, which is to the left, a 1200 Newton force, which is to the right. So obviously, the resultant force is to the left. So the acceleration would also be towards the left, right? That's what Newton's laws tell us. So we can use resultant force equals to MA. So we know that it's going to be 1600 minus 1200 equals to 850 times A. And from this, we just make A the subject of this equation. So let's go ahead and do that. So 400 over 850 basically. It's going to be a value less than 0.5. And the only one here which fits that description is this. Next, an object of mass M is suspended by a spring from a fixed point. The spring has spring constant K. The object is set into vertical oscillations of time period T. Which equation for T is homogeneous with respect to base units? So first off, let's just quickly look at what the base units for K is going to be, because it's really easy to see what it's going to be for T. It's just going to be seconds. So spring constant, this is the defining equation. K would be F over X, X being extension. Force is kg meter per second square, right? Mass times acceleration. This is mass, this is acceleration, divided by units of extension, which would be meters as well. So units for K are kg per second square. Now, if I look at the equation, the answers here, the time period is the subject for all of these. So I obviously need a mass unit to cancel out with the kg, which is there in all the options as well. But also, if you think about it, I want only S to be left, right? If I have this in the numerator, I would always have S and a negative power there, which is not what I want, right? So it can't be K in the numerator, so it can't be this, can't be this. So it's definitely in the denominator. So it's going to be like kg per second square in the denominator and kg here. But even if the kgs cancel out, I'm going to be left with a second square. So to get rid of the square, I would also need a square root. So if you look here, I had m here in the numerator and k in the denominator. So it's root m over k, which is t. Right? So that's the answer to this one. Let's have a look at another one now. An object of fixed mass is initially at rest at point P. The object then moves away from P with uniform acceleration. Which statement describes the resultant force acting on the object when it is moving? Again, I'm not even looking at the options right now. If acceleration is uniform, uniform means constant, then by Newton's second law, the resultant force is also constant, right? That's just how Newton's second law works. So it is constant, but it's not zero. Right? The resultant force is constant because the acceleration is constant as well. Question number 5. a projectile is launched at an angle of 25 degrees to the horizontal with a horizontal component of 13 meters per second. All right, so do make sure that you understand what is written here, just because the diagram is missing. So it tells you this, that if this is the path an object takes, like this, if this is the projectile motion, so it's given you that it's launched here. It's launched, and this makes an angle of 25 degrees with the horizontal, but the horizontal component is 30. All right, they haven't given you this original velocity. They've given you the horizontal component. So this is 30. This is 30 meters per second. And you are asked the vertical component. So let's say if this is the actual velocity before breaking this up into components, you know that v cos 25 would be 13. So from here, you can figure out v as 13 over cos 25, which is 14.3 meters per second. And that's not the final answer still, because you need the vertical component. So the vertical component is going to be this one, which is going to be v sine 25. So whatever answer I have right here, I'm just going to take the sine component of that. So answer sine 25 is going to be 6.06, so 6.1, correct to us. Next, a ball is released from rest at position X at time 0. At 1 second, it bounces inelastically from a horizontal surface and rebounds, reaching the top of the first bounce at 1.5 seconds. This is a velocity time graph. That's the first thing to identify. And I know that the area under this graph is the displacement. It did say inelastic, and this is just to show that there is some loss of energy. So it won't bounce back to its original height. It's going to bounce back to a relatively lesser height. So we can see that at the point when the velocities are positive, right? Because this was released. So this is now falling from rest, and then it falls, it bounces. And then when it bounces, it doesn't go as far up. That's the spot, right? How do I know it's this part? Is because if you think about velocity, it's a vector quantity, and we use the sign convention for that. So if it was falling, the velocities were positive. And when it's rising, the velocities are negative. So the only idea here is this, that the examiner has basically taken a reversed sign convention. What he's done is that he's taken velocities upwards, velocities downwards is positive here, and velocities upwards is negative, which is not an issue at all. Another way you can also confirm this is because you know this is a velocity time graph. The gradient of this graph is acceleration, right? That's also what you know. So gradient is acceleration. And if you see here, in either of these parts, when it's falling or rising, the gradient is positive. And positive again means downwards acceleration, right? So the acceleration due to gravity is downwards. So what is the total displacement of the ball at 1.5 seconds? So it went down by this much, and it came up by this much. So from its original position, right? So let's say if a diagram probably helps here. So let's say it's dropped from here. Yes, so it's dropped from here. And then it falls this far low, which is given by this portion of the graph. Right? And then it goes back up till here, lesser distance, which is given by this portion of the graph. So we can find out the difference, right? Let's figure out the one in red here, which is again really the area of a right angle triangle. So half base into height. So half into 1 into 10. So half times 1 times 10, which is 5. So it falls through 5. And then if I do the one in blue, it's half into 0.5 into 5. So it's 1.25. So it fell 5, it only rose up 1.25. So the difference between the two is what I really need, which is 5 minus 1.25, which is this. Let's go on to the next one. What is the definition of acceleration? Change in velocity per unit time. This is my answer. Or another one that the examiner likes to use is the rate of change of velocity. Rate of change of speed per unit time. This is wrong for two reasons, which is that it's not speed, technically it's velocity. And rate of change of speed and then saying per unit time as well means it's divided by times twice, which is not what's happening, right? It's divided by time and then divide by time again, which is not correct. Rate of change of velocity per unit time. So this does correct what was wrong in B, but it's still division by time twice. So once and then again because of the rate once and then per unit time. So that's also wrong. Resultant for force per unit mass. Is this a correct expression? And the answer is yes. If I write out Newton's second law, and if I make A the subject, F over M, this is exactly what this expression talks about. But is this the definition? And the answer is no. It's just making acceleration the subject of an equation, but the definition is this. Question number 8. Two balls P and Q of equal mass move along a straight line directly towards each other as shown. Ball P has velocity 1.3, Q has 0.5 to the left. P and Q collide, the collision is perfectly elastic and total momentum is conserved. This diagram correctly shows the motion of P and Q after the collision. So if I see here, this is elastic and I'm not given the masses, so I can't, even though it really is going to conserve kinetic energy, I can't use that in my calculations. So I use this idea that the relative speed of approach equals the relative speed of separation. Whenever they are moving in different directions, I would add for the relative speeds. So this is going to be 1.3 plus 0.5, which is 1.8. And that's also what the relative speed of separation must be. In this case, if I were to do this calculation, it would be 0.58 minus 0.22, which is definitely not 1.8. 0.4 and 0.4, again, this is actually a zero relative speed of separation. Because if two things are moving with equal speed in the same direction, they would not have any change in spacing between them. So relative to each other, they are not moving. That's what it means. See 0.19 and 0.99. So 0.99 and 0.19 for the relative speeds, because they're moving in opposite directions, I would add them again. But this is not 1.8 again. By default, and by the process of elimination, this is the answer here. 1.3 to the right, 0.5 to the left. If I add them, I do get 1.8. And this is one type of elastic collisions where the particles basically exchange velocities. So as you can see, this 1.3 now came here, and this 0.5 came here. So this is an elastic collision. A basketball player hits a ball vertically downwards with a speed of 2.4 meters per second from a height of 0.9 meters. Air resistance is negligible. What is the speed of the ball as it hits the ground? Again, there are two ways to do this. The first one is just using equations of motion. So you hit this ball vertically downwards, and I use this sign convention that downwards is positive. So I say that the initial velocity is 2.4 downwards. Acceleration is 9.81. This is also positive because this is also downwards. Height is given, which is s, this is 0.9. And I need to find out the final speed as it hits the ground, which is v. So for this, we use v square equals to u square plus 2as, pretty obvious. So it's 2.4 squared plus 2 times 9.8. Just for v, you are also going to take the square root. So square root 2.4 squared plus 2 times 9.81 times 0.9. which turns out to be 4.839. So 4.8. There's another method, and that's also going to lead to the same answer, which is using energy conservation. So initially, it has kinetic energy and potential energy as well. So if I talk about the energy initially, so it's half mv squared. And again, m is not given, but if you write it out, it won't really even be needed. Plus mgh, so m times 9.81 times h. Let me draw a line here to show that these are separate methods. And then you do the same for the final one, which is just going to be kinetic energy now, no potential energy because it's right at the ground. So half m v squared, right? And then you write out the expression. So you will see that if the initial and final energies are equal, all of the m's cancel out. So you're left with half 2.4 squared plus, and I forgot here, this h is 0.9. So plus 9.81 times 0.9, and this is now half v squared. So half v squared. And you can also find v from here, right? And you can do this as an exercise for yourself. V would be the same. All right. A ball falls through a liquid at constant speed. So constant speed again implies that acceleration is zero, so resultant force is zero by Newton's second law. It is acted upon by three forces: upthrust, drag, and weight. Liquid has uniform density. If it's falling through a liquid, this means that it's going down. And if it's going down, the drag is upwards. By default, upthrust is always upwards, and weight similarly is always downwards. Right? So d plus u is equal to w. It's equal because acceleration is zero, so resultant force is zero. This statement is correct. The drag force increases with increasing depth. It's drag plus upthrust equals weight. The upthrust is constant with increasing depth. Is this true? And the answer is yes, because upthrust is rho g v. Rho is the same, density is the same, g is same, and if it's already beneath the water, so the volume will also be the same. So upthrust will also be the same because all of the factors affecting it are also the same. So the answer for 10 is C. Why is D wrong? Weight is greater than the sum of drag and upthrust, which is also wrong. It's exactly equal. Some solid cubes have mass 1 kg, sides of length 5 centimeters. These small cubes are stacked to form a large solid cubes with side of length 2 meters. What is the weight of the large cube? So if I think about these smaller cubes, let's make a few of these. So we have some cubes like these. All right, and we take these together to form sides of length 2 meters. All right, so if you think about it, each of these cubes is 5 centimeters. So 5 centimeter would mean 0.05 meters. How many of these would I really need? So how many of these would I need to make another one which has a length like this of 2 meters? Right? This is the first thing that we need to answer. And it's really easy to find out. It's just 2 over 0.05. This is the number of cubes that we need, the number of small cubes. So these are 40 of such cubes. So the mass here. So it's 40 like this. No, but actually I'm going about this wrong, right? Because this only gives me the horizontal number of cubes. How would I then find the total number of cubes? So the correct approach in that would be to just figure out the volume of the larger one, the volume of the smaller one, and figure the number of cubes, figure out the number of cubes using that. So volume of the larger cube would be 2 times 2 times 2, basically 2 cube because it's a cube. So that's 8 meter cube. And doing the same for the smaller ones, which would be, so that would be V equals to 0.05 cube, because that's also a cube. So 0.05 cube. So that is 1.25 into 10 to the negative 4. And then I can divide this by this to figure out the number of cubes. So my number of cubes would be 8 over this 1.25 into 10 to the negative 4. So 8 over this, which is 64,000 cubes. I know the mass of one such cube is this. So 1 times 64,000 is obviously 64,000. 64,000 kg, and I just use W equals to mg. So just multiply this by 9.81, right? So 64,000 times 9.81 turns out to be 6.27 into 10 to the 5. So 6.3 into 10 to the 5, and in prefixes 0.63 meganewton. Right, that's how we do this one. Question number 12, a borehole of depth 2000 meter contains both oil and water as shown. Pressure due to the liquids at the bottom of the borehole is this much, and it's basically two liquids sitting on top of one another. And if you remember how we do this is basically we add the pressures because of both of these liquids because of their depths. And the reason is pretty simple is because it's basically both of their weights which are acting at the bottom, right? So that's why we add the pressures. So if I look here, this is where I want to find the pressure. If all of this is 2000, if this is X, so this is 2000 minus X. Why do I need this? Because I need to find the pressure for oil and volume separately, and then I need to add them. So pressure of water is going to be rho GH. Rho water is 1000. G is 9.81. And this is 2000 minus X. And similarly, if I do the same for oil, so it's 1000, not 1000, it's 830 times 9.81 times X. And then I add both of these. Why did I make a row here? It's supposed to be P. So their pressures should equal this value given. Mega is 10 to the 6. Then we just work this out. 1000 times 9.81 times 2000 is 1.96 minus the 1000 times 9.81 times X. So this was 1.96 into 10 to the 7 minus 9810X plus 830 times 9.81 times X, which is 8140X. And this is equal to 17.5 into 10 to the 6. So just solving a bit more. 9810 minus 9810 plus 8140 is minus 1670. X equals to this value. So then I just subtract. So this is really 1.96 minus 1.75 into 10 to the 7. So this is 0.21 into 10 to the 7, and to solve for x, I'll just divide by 1670. So x turns out to be 1257, and that's again just because of some rounding error, because the answers here are needed in 3SF. So I really should have taken these to be 4SF, but this is an MCQ, so it works. So the answer to 12 is D. Just complicated algebra, not really anything too difficult. A rod is pivoted at one end. Initially, the angle theta to the rod initially the angle theta of the rod to the horizontal is 0 degrees. Weight of the rod causes the moment m about the pivot. The rod is then rotated in the vertical plane so that the angle theta of the rod increases from 0 to 180, which graph shows the variation of m with theta. Again, a lot of words, so let's just make a small diagram for ourselves. This being the rod. So let's tilt this to show the angle. And it's pivoted at one end. Let's say it's pivoted from here, right? This is the pivot. So with this pivot, the weight of the rod itself causes a moment. This is the weight. So let's make a larger arrow. So this is the weight. And the angle with the horizontal, which would obviously be this one, this is theta. Now, if this is theta, then this would be 90 minus theta, and then this angle would be theta again. So when I break this up into components, this would be components like these, with this one being a W sine theta. And this one right here, let's change the color. This one being a W cos theta. Now we know that the W sine theta would not create a moment. It's only the W cos theta which creates the moment. So it's going to be W cos theta times whatever this distance is d. So the moment would be W d cos theta, right? All right. So we know for a fact that when theta is 0, cos theta is 1. You can also do this on your calculator right now. So cos 0 is 1. So this means that it has to have a maximum value at first, right? But we also know from polarization the shape of the cos graph. So it's neither this nor this. A is outright wrong because it just shows a constant moment, which it's obviously not. It's going to change because of the angle. And it's not linearly decreasing as well. So I know that cos 0 is 1, and then as theta gets larger, cos theta decreases. So this is correct for both of these. But then if we look at them, the difference between both of these is this, that one shows a positive moment throughout, and the other one shows a negative moment. Now, what do we select here? The idea is this, that because moment is by definition a vector quantity, direction does make a difference. So the idea here is that it would be negative as well, right? Your cos is going all the way from 0 to 180. If you do it till cos 90, at cos 90 it would be 0, but any angle more than that, it would start to be negative. That is why the answer here is D. And it makes sense. Let me show you why in a explanation that does not involve as much math. Right now, if I am tilting this rod, the weight is acting in a way which is going to make it fall clockwise, right? Let's do a simple experiment. So I have this diary and I'm tilting it like this. So the weight is going to make it fall in this direction. It's going to make it fall clockwise. When I pass this 90-degree angle and when I increase the angle further, it's going to fall in the opposite direction, right? Now it falls anti-clockwise. So it's a difference in direction, which in vector quantities is indicated by a negative sign, which is why in this case, the answer is not going to be B, it's going to be D. All right, it's going to be negative. All right, question number 14. A hinged trapdoor is held closed in the horizontal position by a cable. Three forces act on the door: weight, tension, and force H at the hinge. Which list gives the three forces in increasing order of magnitude? Well, there are some equations that I can write right away. Let's say if I call this some angle theta and I call this some angle alpha, and I can obviously see that theta is larger than alpha, and we'll get to that in a moment. Resolving the forces, I can say that this is going to be T sine theta, this is going to be H sine alpha. So this is, let's mark these. This is T sine theta, and this is H cos alpha. Sorry, H sine alpha. H sine alpha, T sine theta, right? And then I can write a equation in terms of the equilibrium in the vertical direction. So I can say that upward force equals downward forces. So I can say T sine theta equals H sine alpha plus W. Now W plus something else is T sine theta, right? And sine theta, sine alpha, if I look at this, sine of any angle is always going to be between 0 and 1, right? At least for acute angles, that's what you need to know. So this is 0 point something equals 0 point something. So 0 point something T equals 0 point something H plus W. If you guys want me to write it out in numbers, I will. So 0 point something something T equals 0 point something something H plus W, right? So something here is being added on to W. So this overall thing is going to be more than W, right? And when it's divided by a value which is smaller than 1, it would make it an even larger value. So one thing is for sure that when we analyze these numbers, T is definitely greater than W. On the basis of this thing alone, I can strike out some options. Because it's increasing order of magnitude, so we're going from smaller to larger to larger. So since T is more than W, I need an order where T comes after W. So it definitely can't be A or B. And now if you look at the options left, it's between H and T. Now, how do we decide between H and T? In this case, what we can also do is we can see here that there would also be a horizontal equilibrium of forces. So there would be a force like this, there would be a force like this. This one would be H cos alpha, and this one would be T cos theta. Because this is an equilibrium, both of these forces would also be equal. So I would say T cos theta equals H cos alpha, right? Now that's decided. Now, how do we decide between what's greater, T or H? Now here we do need a slight understanding of how the cost ratio works. The idea about ratios and what you need to know, let me just write it down here on the side. Let's say we have an angle theta. Let's say theta goes up. And I'm talking about acute angles right now. If theta goes up, and let's say theta is an acute angle, so it's between 0 and 90, right? If theta goes up, sine theta will go up and cos theta will go down. This is something you need to know. It's written nowhere in the AS syllabus, but it's one of those unofficial things which we just expect students to know for AS. Now the idea here is this, that because theta is greater than alpha here, let me write it out here. Because theta is greater than alpha, because theta is a larger angle, its cost would be smaller. So cos theta is less than cos alpha. You just also saw this in this graph. Smaller angle, larger cost value. Larger angle, smaller cost value. All right. Now, if for a moment I make T the subject of this equation, so it becomes cos alpha over cos theta times H. Because cos alpha is greater than cos theta, this means this is a fraction where a numerator is larger than the denominator, right? So a number like 7/4. this fraction is going to be more than 1. Because of this, T would be greater than H. So T is also larger than W, T is also larger than H, T must come at the end, then C is the correct answer because of this reason. All right. 15. Definition of force. Again, this is numerically equal to the resultant force, but it's not the definition. The definition is this, the rate of change of momentum, and the reason is pretty simple. That when you define force as the rate of change of momentum, this also allows you to take into cases where the mass is changing. 16, a boat moves at constant velocity through still water. A constant force F acts on the boat. What is the power used by the boat to move through the water? Also, it's pretty simple, that it's force times velocity. That's one of these power formulas. That's the power developed by this force. So it's just Fv. P equals Fv is what we've used here. 17, the diagram shows 4 forces acting on a circular disk. Each force is magnitude F. 2 of the forces act vertically. Other 2 forces act horizontally. All forces act in the same plane. No other forces act. Disk is diameter d. Statement. Which statement is correct? So on a very quick glance, you can see that this and this form a couple, and this produces a clockwise movement. This and this form a couple, which also produces a clockwise movement. So it's definitely not in equilibrium, right? On any object on which a couple acts, it's not in equilibrium. So the disk is not in equilibrium, and then the reasons are different. The first one says the resultant force is F. This is wrong. There is no resultant force on couples. Because of couples, one force like this, the other one like this, these two cancel out. Because of one force to the right, the other one to the left, both of these cancel out. So there is no resultant force, there is a resultant moment here. And the formula is this, that it's the force, it's a distance between the 2 forces times the magnitude of any one force. So this is d, and because it's a diameter, this is also d. So Fd because of this couple, Fd because of this couple makes the total 2Fd. 17, a ball is projected into the air from horizontal ground and follows the path shown. At points Q, R, S, and T, ball has kinetic energies EQ, ER, ES, ET. Heights are given. Air resistance is negligible. Which difference in kinetic energies is the smallest? Seeing the weight energies and kinetic energies means that I want my difference in kinetic energy to be the smallest. And we know that in projectile motion, there is a certain interchange of energy. Because I want my change in kinetic energy to be the smallest, then by conservation of energy, I also want the change in my potential energy to be the smallest as well. And for my change in potential energy to be the smallest, my change in height must also be the smallest. If I look at the first option, EQ minus ES, so this is 1.5, this is 1.6, the difference is only 0.1. ES and ER, 1.8 and 1.6, this is a difference of 0.2. ET and EQ, so EQ and ET are 1.5 and 1.3, the difference is again 0.2. ET minus ER, the difference is 0.5. Smallest difference in height leads to the smallest change in kinetic energy as well. 19, the battery of a small tablet computer is initially uncharged. It is connected to a constant 10 watts power supply for 2 hours to charge the battery. Efficiency is 80%. What is the total energy stored in the battery? So using the power and time, I can calculate the energy, which is really going to be the energy input, because this is what the battery needs from a supply, right? So it's power times time. Power is 10, time is in hours, so 2, and each hour is 3600 seconds. How did I get that? Is because each hour contains 60 minutes, each minute of that contains 60 seconds. So this turns out to be 72,000. And then if we use the efficiency formula, which is output over input, either for energy or for power, So total energy stored in the battery charging process has an efficiency of this much. So output, which is what is finally stored as a result of the charging process, which is 0.8 times 72,000, which is 57,600, so C. An initially stationary firework explodes and splits into two fragments that move horizontally in opposite directions. Total KE transferred is E. One fragment is mass m, the other one has mass 2m. What is the speed of the fragment of mass m immediately after the explosion? The firework was initially stationary. So if I make a small diagram here, this is my part of mass m, this is 2m. So this is m, this is 2m. Because total momentum before was zero, by conservation of momentum, total momentum afterwards must also be zero. So if this moves with some velocity v to the left, this would move with half the velocity to the right because it also has twice the mass. Pretty easy. This momentum would be mv to the left, this would be mv to the right, and they cancel out, right? So that's what the speeds must be. So what is the speed of the fragment of mass m immediately after the explosion? So I really need to figure out v in this entire setup. So I know that half the kinetic energies of both of these, the sum of that must equal E. So half mv square plus half into 2m into v by 2 squared of these is equal to E, right? These cancel out. So this becomes half mv square plus mv square plus 1/4 of mv squared. So half plus a quarter becomes 3/4 mv square equals E. So if I just make v the subject from here, this becomes 4e over 3m under the root. So d. 21. A spring is fixed at one end and extended by applying a force F to the other end. The spring has extension X, elastic potential energy EP. Spring constant is K, obeys Hooke's law. Which relationship is correct for the spring? EP is not just proportional to F. Now you guys might ask, why is this so when I know that the formula is half Fx? Is because F and X are also related within themselves, right? So that's why this is wrong. We can't just say it's directly proportional to F because the extension varies with force, right? It's not like this is a constant. So that's why I can't say that half X is a constant, which is why EP is proportional to F, because X is not a constant, right? EP is not proportional to X because of the same reason, because this is a constant now, and it's quite literally called the spring constant. So I can say all of this is a constant. So EP is proportional to X squared. So this was wrong. This is also wrong because if it obeys Hooke's law, this means that the spring constant is quite obviously a constant. 22, a force extension graph is produced for a metal wire. What must describe the limit of proportionality? Point at which the wire breaks. This is not the limit of proportionality. Point beyond which Hooke's law is not obeyed is the limit of proportionality. The point beyond which the wire cannot return to its original length, this is the elastic limit, right? After this, plastic deformation happens. And the point beyond which the wire starts to form plastically, this is really also the elastic limit. Why does it say must? Is because for some materials, the limit of proportionality and the elastic limit may be so close together that you don't know the difference, right? But again, that's for some materials. This is a universal statement that applies to all materials. That is how we define the limit of proportionality. 23, a spring has a spring constant of 6 Newton per centimeter. It is joined to another spring whose spring constant is 4 Newton per centimeter. The load of 80 Newton is hung. What is the extension of this composite spring? This is an example of springs in series. So we add the extensions of both of these to get the total extension. So F equals to Kx. So X is going to be F over K for each of the springs. So 80 over 6 and 80 over 4. 80 over 4 is 20, and we would add this as well. Now, obviously, there's only one option which is more than 20. So that's 33. Easy. And by the way, this question is also an older question. It's nothing new. The range of frequencies of sound emitted by blue whales is given. Speed of sound is given. What is the approximate range of wavelengths of sound waves emitted? So we can use the frequencies to find wavelengths, no big deal. V equals to F lambda. So lambda equals V over F. So 1500 over 10. So one of these is definitely 150 meters. If I look at the options, must be this. Also, I hope that you guys observe that the smaller frequency leads to the larger wavelength here, right? If you do it with 40, the answer should then be 38. A sound wave is detected by a mic and displayed on the screen of a CRO. Frequency of the wave is given. What is the setting on the time base? If the frequency is given, I can first find out the time period. So T would be 1 over F. So 1 over 2500, which is 4 into 10 to the negative 4. What is the time period in terms of the time base? It's the time base multiplied by the horizontal divisions in which one wave forms. In this case, it's 1, 2, 3, 4. So times 4. So this would be 1 into 10 to the negative 4, which is 0.1 milliseconds per centimeter. Again, easy. Next, a source of sound waves with constant frequency moves towards a stationary observer. The observer compares the sound waves arriving at the observer's position with the waves emitted by source of sound. What is detected by the observer? Because this is moving towards the observer, it's going to be a increased frequency, right? So it's definitely going to be an increased frequency, but I don't see that here. It's the same thing as saying a decreased wavelength, right? Increased frequency leads to a decreased wavelength. So it's the same thing. This type of wave cannot be polarized. We know that a longitudinal wave cannot be polarized. So the only longitudinal wave here is this. The other three are part of the EM spectrum, so they are transverse. Are definitely one of the harder questions of this paper, but not really all that hard, honestly. And this paper, all in all, was also not that hard. A beam of light with power P has an area of cross-section A. Amplitude of light waves in the beam is X. So you are given amplitude, and right at this point, coupled with this information, power, and amplitude, and area, this should trigger a word in your mind, which is intensity. So we know intensity is power over area, and also we know this relationship that intensity is proportional to the amplitude squared. So the beam of light is then changed to 1 with the same frequency, but with an increased amplitude of 4x and an area of cross-section reduced to A by 3. We need to find the new power, so let's make power the subject of this equation. So this would make it power equals to intensity times area, right? So power equals intensity times area. Now, if you see here, because amplitude quadruples, because of this relationship, the power is going to increase by a factor of 4 squared, which is really 16. And then because of the area becoming 1/3, the power would also become 1/3. So this is 1 over 3. So I'm looking for 16 over 3 times the initial power, which is going to be 5.3. So that's P. 29. Two loudspeakers are connected to the same SIG-gen. The SIG-gen produces a single frequency. Loudspeakers face each other so that a stationary sound wave is set up in the region between the loudspeakers. Mic is moved with the CRO. So the bottom line is this, that you see 5 maxima as the microphone moves. And then the microphone moves a distance of 2 meters from the first to the 5th maxima, and you are asked the wavelength. So maxima, 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 and maxima. And this distance between the two, this is 2 meters. right? So if I see how many wavelengths these are, so this is one. So antinode to antinode is half a wavelength, just like a node to node. So half one, 1.5 and 2. So this is 2.0 wavelengths. So 2 meters basically equal to 2 wavelengths. So each wavelength is exactly 1 meters. Two waves emit coherent waves. Two wave sources emit coherent waves. What condition must be correct for coherence? So coherence is same frequency, constant phase difference. They could be emitted in phase, but it's really a constant phase difference, right? If they're moving in opposite directions, as is the case for stationary waves, the phase difference is changing. Same amplitude is not a requirement for coherence. 31, a student sets up an experiment to investigate double slit interference. The student uses light of a single wavelength from a laser to illuminate a double slit, leading to interference. Student finds fringes are very close together. What could the student decrease in order to increase separation? So separation of the fringes is basically x. So lambda equals ax over d. So x equals lambda d over a. The only thing that could increase x as a decrease is a decrease in a. Right? Decrease in a is going to decrease the denominator, making the overall fraction larger. So a is the slit separation, which here is called r. The answer to 31 is C. What are the definitions of potential difference in EMF in terms of energy transfer and charge Q? So energy transfer and charge Q, just the definitions in terms of the formula are exactly the same for both of these. It's energy transfer per unit charge for both of them. The diagram shows a network consisting of 3 resistors. What is the combined resistance between X and Y? So it's 2.2 in series with the parallel combination of these. So you can use product over sum, or I choose to use this 1.2 inverse plus 4.7 inverse, right? This is just that formula 1 over R effective equals 1 over R plus 1 over R, as many resistors as you have. So 1.2 inverse plus 4.7 inverse is 0.9559, so 0.956. And there's a 2.2 in series as well. So you add 2.2 to that. So it's pretty obviously this. Next, 3.4, a resistor dissipates 25 watts of power when there's a potential difference of 4 volts across it. What is the resistance? Power, voltage, resistance, P equals V square over R. That's the most convenient thing to do. You could also choose to use P equals VI, then find out the current, then find out the resistance. This is the smart thing to do. So R would be V square over P. So 4 square over 25. So that's what, 16 over 25, which is B. All right, let's go on to the next one. The diagram shows a cell with internal resistance connected in parallel with a fixed resistor and a variable resistor. Resistance of the variable resistor is decreased. So this resistance goes down. What happens to the potential difference across the variable and the current in the variable resistor? If this resistance goes down, this entire parallel combination, the resistance of this goes down. So this is now a smaller fraction of the total resistance. So it's V across the variable resistor, right? Yes. So because it's a smaller fraction of the total resistance, so the voltage across that also goes down. So V definitely decreases. And because resistance has gone down, current would increase. So current in the variable resistor is also going to increase. So that's B. 36, also another repeated question. A radioactive source produces a beam of alpha particles in a vacuum. Average current caused by the alpha particles is 1.5 into 10 to the negative 9. Beam is incident on a metal target. What is the average number of alpha particles hitting the target in a time of 3 seconds? So current, time, we can find out charge. So Q equals to I P 1.5 into 10 to the negative 9 times 3. This would be the charge. Which is 4.5 into 10 to the negative 9. Don't know why I picked up the calculator for that. Almost shameful. But anyway, so we know that charge is basically quantized in terms of the particle carrying that charge. We have alpha particles here. And if you think about an alpha particle, which is basically a helium nucleus, it has a charge of 2e. So twice of the fundamental charge. This is for one alpha particle. And for n particles, this would be the total charge. Right? This is the total charge. This is the charge of one alpha particle. So if I multiply the charge of one particle by the number of particles, I can get the total charge. So from here, I just make n the subject. So 4.5 into 10 to the negative 9, 2 into 1.60 into 10 to the negative 19. So n turns out to be 1.4 into 10 to the 10 C. Easy. On to 37. Charge carriers in a metal wire free electrons. Which statement about the charge of each free electron is correct? Magnitude of charge increases with potential difference. No. Magnitude of the charge is 0. No. Sign and magnitude of the charge do not depend on the potential difference across the wire. True. For a charge carrier, it does not depend on the current or on the potential difference. So this is also wrong. Which flavors of cork have charge positive 2 by 3e? Now we're in luck because I always talk about cork flavors like these. So U, C, T. So U is not there. C is definitely plus 2 by 3. And top is plus 2 by 3. So that's A. 39. A unstable nucleus of an element decays by alpha and beta emission to become a nucleus of a different element. The nucleus is unstable and emits an alpha or beta. The process continues until an isotope of the original element is produced. For the isotope to be produced, this means that the proton number is the same. So let's say I start off with a particle, let's call that D. So this particle D has some nucleon number, some proton number. It decays to give us E, and let's say it undergoes alpha emission first. Right? It undergoes alpha emission. So this means the nucleon number decreases by 4, proton number decreases by 2. Now what we need to do in the subsequent decays is we need to get the proton number back up to Z. That's how it's going to be an isotope. So we have beta negative then. And beta negative does nothing to the nucleon number. So let's not write that anymore. But it does increase the proton number by 1. So this then becomes Z minus 2 plus 1, which is Z minus 1, and then another 1. So let's say if you're talking about G, so this increases it by 1 again, and this becomes Z again. So what is the minimum possible number of particles emitted? So it's 3. 1, 2, 3. Why does it say minimum? Because it could then emit another alpha and then 2 more betas, and that would also be an isotope, right? So this is the minimum. A nucleus of carbon-10 decays by beta emission to form a nucleus of boron, which is 10.5. For this decay process, what is the change to a nucleon? What is the change in the quark composition of the nucleon? So this is again very easy for beta emission. If I look here, this is definitely beta positive, right? This is beta positive because the proton number decreases. So beta negative is neutron to proton, beta positive is proton to neutron. And the change to the quark composition, proton is U, U, D, neutron is U, D, D. So an up becomes down, that's B. All right, so that's this entire paper then. I hope this actually serves to help you guys because just the mark scheme is here and pretty sure some of you might not be able to understand how an answer is reached. So this is what I could do for you. So best of luck for your exam, guys, and do also subscribe to my channel because I'll be sharing more useful resources like these for you guys so that you guys can bring your A game to the exams. Also, if you guys have any video ideas of your own as to what might help, do let me know in the comments. So until next time, guys, bye.